keep going. Now, we're going to kind of do everything in one here. And what's a little tougher is so far in this lesson, all of the angles that we have been using have been either special angles from our table that you have memorized, or their reference angles are in that table, and you use all students take classes to figure out what it is. So you'll notice I haven't used a calculator. I'm still not going to use a calculator, but what's different about these is that it's telling us that the sine of our alpha, or our angle A, is 3/5. That is not one that I have memorized in the table. So what I'm going to do is, this is angle alpha, and it's telling me that angle alpha is between 0 and pi over 2. So 0, pi over 2. So let's do just this angle here. So this is angle A. And if I were to make a right triangle, it's telling me that the sine, which is the same as opposite, so opposite, which is 3, over hypotenuse, which I guess, let me move this real quick. The hypotenuse is 5. I can find my x value, right, knowing my Pythagorean theorem. Now, if you needed to do the work, right, 3 squared plus x squared equals 5 squared, you totally could. But this is a special one that hopefully you have memorized from geometry. This is called a 3, 4, 5 right triangle, right? That's how it always is. If one of your legs is 3 and your hypotenuse is 5, the other leg has to be 4. Let's do the same thing for angle B. Now, angle B is between pi and 3 pi over 2. So here's pi, here's 3 pi over 2. All right, so that's going to be in the third quadrant. So I've got x, y, and the hypotenuse. I know the hypotenuse is always positive. So that's 13. Excuse me, but if you notice, my x is actually -5. My adjacent side from my angle B, right, is going to be x. And if you knew your understanding from geometry, that's another special one, 5, 12, 13. So this is going to be 12, but I tell kids all the time, if you look, we're in the third quadrant, so we're going down. So actually, this is going to be y equals a -12. All right, so just be careful there that, with angle A, it was in the first quadrant, so everything's positive. That's not true if you're in a different quadrant. All right, so with all that being said, I got the whole page here. Let's try to find these four. So the first one is the sine of A plus B. So using my formula, that's the sine of A times the cosine of B plus the cosine of A times the sine of B. Now we know the sine of angle A, that's 3/5. We know the cosine of angle B, that's -5/13. But we're going to use these triangles over here, right, the drawings that I made, to find the cosine of angle A and the sine of angle B. So remember, cosine is adjacent over hypotenuse, so that's going to be this 4 here over the hypotenuse of 5. And then the sine of angle B is going to be the opposite side, which is -12 over the hypotenuse of 13. All right, so if I do my algebra and get my answer here, this is going to be -15/65 plus -48/65, which equals -63/65. All right, so that's it for the first one. Let's try number 2. Now, number 2 says the cosine of angles A plus B. All right, so to do that, I'm going to do, remember, you do cosine of A times the cosine of B. Do the opposite sign, so minus the sine of A times the sine of B. All right, so we don't know cosine of A, but we found it when we did the first one. The cosine of angle A was 4/5. We do know the cosine of B. That was -5/13. That was given to us. Minus, we know the sine of angle A. That's 3/5. And we found the sine of angle B from our sketch on the last one, negative 12/13. All right, doing the algebra again gives me negative 20 65ths minus a negative 36 65ths. All right, so if I want to get an answer here, all right, I'm going to do negative 20 minus a negative, which is really addition. So plus a positive 36 is going to be 16 65ths. Okay, so that's it for number 2. Now let's do number 3. Number 3 is the tangent of A plus B. These are going to be a little trickier because we'll need to find tangent. We don't know that one yet. So the tangent of A plus B, using my formula, that's going to be the tangent of A plus the tangent of B over 1 minus tangent of A times tangent of B. Okay? So we're going to go ahead and get the tangent of angle A, which is opposite over adjacent, is going to be 3/4 based on our triangle, plus the tangent of angle B, which is actually going to be a positive because we're in the third quadrant, right? All students take T for tangent. The opposite side of that is going to be negative 12 over the adjacent side of negative 5 is positive 12/5. All right, so over 1 minus 3/4 times 12/5. All right, keep going. Get a common denominator. All right, I'll show my work here. My common denominator is 20. So if I multiply by 5, that's going to be 15/20. Plus, if I multiply by 4, that's 48/20. All over 1 minus, let's multiply. And we get 36/20. And we keep going over here. So that's going to be 15 plus 48, which is 63/20. All right, divided by 1 minus 36/20. So 1 is the same as 20 over 20. 20 minus 36 is negative 16, so negative 16/20. And if you were to rewrite this, that'd be 63/20 times, and you want to do the reciprocal, which is 20 over negative 16. You'll notice the 20s cross out, so you get negative 63 over 16. So that's it for the tangent of A plus B. All right, let's do our last one, which is the tangent of A minus B. Perfect, got enough room here. So tangent of A minus, oh, sorry, I put it together, of A minus B. All right, that's going to be the tangent of A minus the tangent of B all over 1 plus the tangent of A times the tangent of B. So let's plug in this stuff. So it's the same stuff, guys. Excuse me. But we have different signs going on. So 3/4 minus 12/5 all over 1 plus 3/4 times 12/5. All right, if you get your common denominator again, it's going to be the same thing, 15/20 minus 48/20 all over 1 plus, and this becomes 36/20. So that's no different. All right, the signs are different, so that's going to change where I keep going with my work. So I've got 15 minus 48, which is going to be negative 33/20 all over 1 plus 36/20. If I change that 1 to be 20 over 20, that gives me 56/20. Let's make this look a little nicer. So negative 33/20 times 20 over 56. You'll notice those 20s cross out. And you get negative 33 over 56. All right, so that's it for that page with tangent. Okay, now the very last thing we're going to do is we're going to use these new trig identities, right? Our sum and difference identities with sine, cosine, and tangent. And we're going to try to do something we did in the first lesson, which is use identities to make one side of the equation look like the other. So we know what the answer is. We just have to show the steps to get there. Okay, let's do this first one. I think the left side looks more complicated. So I'm going to write out the sine of a plus b, which is the sine of a times the cosine of b, plus the cosine of a times the sine of b, all right? And then plus the sine of a times the cosine of b minus the cosine of a times the sine of b. So all of that I just wrote out is the same as this left side. Now, when you look at what we've got, you should notice that the second, right, so this term, and the fourth term are actually opposites of each other. And when you add opposites, you're going to make 0. So if you bring down the sine of a times the cosine of b plus the third term, sine of a cosine of b, you'll notice these are the same. And so if this is like 1 for each of them, 1 plus 1 would give you 2 times the sine of a times the cosine of b, which is what we were trying to get. All right, so that checks out. Okay, let's do that with this one as well. I'm going to take the numerator, which is the sine of a minus b, and expand that using one of my identities. So the sine of a times the cosine of b minus the cosine of a times the sine of b. All right, all over cosine of a times the cosine of b. Now, this is 2 terms in the fraction, the numerator, I should say, of the fraction, and we have 1 in the bottom. So what you could do is actually take this and expand it to imagine that they both had this common denominator. So let's go ahead and do this. Sorry, let's put it all over one fraction, that is. Okay, so now hopefully you're going to see some stuff cross out. I missed that's supposed to be an A. There we go. You should see some things cross out, like, for example, the cosines of b's here and the cosines of a there. And if you know your identities from the last lesson, or even really from the first unit, the sine of a over the cosine of a is the same as the tangent of a, right? This right here is the same as tangent. And the sine of b over the cosine of b is the same as the tangent of b, which is what we were trying to get up here. So that equals tangent of a minus the tangent of b. So that checks out. All right, one more, and then we'll be finished. So we have the tangent of pi minus theta. So let's go ahead and expand that. So that's the tangent of pi minus the tangent of theta all over 1 plus tangent of pi times the tangent of theta. Now, if you need to go back to your quadrantals for tangent of pi, right, here's pi. The ordered pair is -1, 0. This is our x, and this is our y, which is cosine or sine. And if you remember what we just talked about the previous problem, that tangent is sine over cosine, the tangent of pi would be 0 over -1, which is 0. So this becomes 0 minus the tangent of theta over 1 plus 0 times tangent of theta. So if I keep going with that, I get the opposite of the tangent of theta over 1 plus 0, right? Anything times 0 is 0. And if you reduce that, you get negative tangent of theta over 1, which is the same as the opposite of the tangent of theta, which is what I wanted, right? I wanted this to be equal to the opposite of the tangent of theta. All right, okay, that's it. So hopefully you'll get some practice with these different sum and difference identities. And like I said, we'll make sure you're ready for the formula quiz on these as well. Good luck.